Hello, Science Lights. So it's looking distinctly un-Instagrammy around here. It's nearly the summer holidays and I'll have a tidy up. Hello! We're skidding towards the end of Coral Reefs, aren't we? I'm Lara, you're the Science Alliance. It's lesson 6, surely none of you are new. We've done where corals are. We've looked at models of them. We've made little models of individual polyps. Next week's our last lesson. We're going to look at fossils. We have been looking a lot at how fossil reefs are threatened. So we've looked at bleaching. You remember when the oceans get very hot, maybe they get a lot of light. The algae, the kind of plant-like things that are living with the coral, they make too much oxygen, coral gets very stressed, kicks the algae out. That's coral bleaching. That is bad. Last week we looked at overfishing, also bad. Today we're looking at acidification, which is also bad, but we do get to do a cool activity. If you've got some eggshells with you, the first thing you need to do is to scrunch them up as small as you can and put them into, you could just put them into a jar. We're basically just going to mix eggshells and vinegar. If you haven't got eggshells, you can use bicarbonate of soda, that's fine. I'm putting them in a narrow-necked bottle and sticking a balloon on top just because that's like the full fun activity, but we are concentrating more on the chemistry stone. So if you haven't got a narrow-necked bottle and you haven't got a balloon, don't worry about it. Right, so the first thing you need to do is to get eggshell into a narrow-necked bottle, which is not super easy. Is it really? It is really gross that I'm using eggshell that I crushed up like 3 years ago when I first started doing these shows. When I did this yesterday on Facebook, just this horrible cloud of 3-year-old eggshell rose into the air. But I'm still alive, so I'm just going to do it again. But hopefully you've got fresh eggshells. So put the eggshells into the bottle. Oh. Eggshells are made of something called calcium carbonate. That is so grim. I'm just going to get the lid on that. Can you see the wafting bits of eggshell? Eggshells are made of calcium carbonate. Obviously, if you're using sodium bicarbonate, it's the same thing, except the eggshells have got calcium in place of the sodium. Calcium carbonate is 3 different particles stuck together. What particles do you reckon it is? If I tell you that in chemistry, if something's got an 8 on the end, then it means it's got particles in and one of them is oxygen. Calcium carbonate. What do you reckon? 8 means that it's got oxygen in. Calcium carbonate, did you get it? It's calcium and carbon and oxygen all put together. That's what eggshells are made of, and it's also what little polyps, coral reef skeletons are made of. So this is a very good model for acidification. So first of all, we'll just look at how polyps make that. It took me ages, this little PowerPoint. It's going to take about 3 seconds to show you. Look, there are carbonate particles in the ocean. 3 oxygens and 1 carbon bonded together. And there are calcium particles in the ocean as well, floating around. And the little polyp, this isn't how it happens, but the little polyp takes in carbonate and calcium and excretes it, and this forms its skeleton. It's what the skeleton is made of. There you go. That was it. I hope that you enjoyed it. More of that in a bit. So calcium carbonate is actually a crystal. If I'd been a bit more organised, I might have told you to do that salt activity. You know, you get salt, which is just particles of sodium and chlorine. Sodium chloride, yeah. Sodium and chlorine stuck together. If you mix them into hot water and then you pour them onto a plate and you let it cool down slowly, you will see that crystals form of sodium carbonate, of salt. Water is a crystal, and calcium carbonate, the stuff that is inside eggshells and is inside skeletons, that is also a crystal. So they secrete it and it grows around them. Right, we're talking about acidification, so we need to add some acid to our calcium carbonate and see what happens. Maybe I'll do that now. Are you all right? Are you all caught up? Have you got your eggshell all scrunched up and stuck in a bottle while I was talking? Did you? Did you? Okay, I'll add some acid in a bit. Get going, and I'll do it in a few minutes. What is acidification and what causes it? Well, acidification is, I'll do this just to make sure that you've all caught up and you've all got your eggshells in your bottle. I think the easiest way to describe it is, imagine you've got some blue paint and you've got some red paint, okay? And this is your scale from red to blue. and back again. If you got a little, and this is purple in the middle, I suppose, isn't it? Because if you've got equal amounts of red and blue, then you've got purple. If you get a drop of red paint and you add it to some blue paint, what have you got? You haven't got blue paint, have you? But you could say that you have made your paint slightly more red. Is that okay? You get some blue paint, you add a drop of red, you've made it more red. It's not red, it's not even purple, but you've made it more red. This is what I'm trying to get at with ocean acidification, is a lot of people think that ocean acidification means that the oceans are becoming acidic, like you would be swimming in an acid. That is not quite true. So let's put acid over here, and the opposite of acid is alkali. Alkali. We will do a whole module on this, so I don't want to go into it too much. But if you imagine that the opposite of acid is alkali, and in the middle you've got neutral. Something that isn't acidic or alkali. Like if you mix an acid with an alkali, you can make something neutral, right? So this is quite a good model. What's happening is the ocean is actually slightly alkali. It's the ocean's probably, I don't know. It's slightly alkali. What's happening is ocean acidification is when the ocean becomes more acidic than it was before, but it's not actually acidic. It's not even neutral. So maybe like this is now, and this is later, and this is later still. So it's becoming more acidic, but it's not actually an acid. Is that all right? Does that make sense? Let's have a look at how it becomes an acid. Carbon dioxide in the atmosphere is being caused by humans more and more and more. Ever since we invented like machinery and steam engines and learned how to burn coal, we have been putting more and more carbon dioxide into the environment. It's bad for a lot of reasons. It's causing the planet to heat up. It's also bad for the oceans. I will show you why. Let's go back to my PowerPoint again. Here we are. So now we've got calcium carbonate. This is the skeleton of the polyp. We've got some water particles. We'll forget about our polyp for now. Let's just think about what happens to these water particles when carbon dioxide from the environment goes into the ocean. Well, what happens is they join together, right? You've got CO2, carbon dioxide, water, H2O, hydrogen and oxygen and carbon particles, just all get together to form, it is actually an acid, but it's a very unstable particle, this. It's called carbonic acid. And what happens is it straight away breaks up, and the hydrogen particles kind of pop off. So you've got a bicarbonate particle here, and a hydrogen particle all on its own, and that is essentially what acid is. So if you've got some vinegar with you, that vinegar has got hydrogen particles in it, and you could sort of say that it's the hydrogen particles that make it acidic. If you've got loose hydrogen particles, you've got an acid. So, right, now, hopefully you've caught up. Let's add some acid to our calcium carbonate and see what happens. And then, if you've got a balloon, you could quickly stick the balloon on top, and we'll catch the gas that is given off. Sticking my balloon on top. Oh, beautiful. This is so lovely, this. You'll have to excuse a lot of Lego story time in the background. We're doing a show about dogs this morning. But instantly, like, I haven't even shaken it. You get this gorgeous bubbling. Look at that. I mean, if you're a vegan, if you don't have eggshells, you might find this slightly disgusting. We've got this, like, eggy membrane all bubbling up. Look at that. And you can see already something is happening. Look! Is your balloon sticking up? Mine is. That is just amazing. I'm going to close up. I'm sorry. I can't help myself. So interesting. So this is a chemical reaction, okay? Particles of the calcium carbonate eggshell are popping off and rearranging, mixing with the hydrogen particles in the acid and forming a gas. I'm not going to give you 10 clues as to what that gas is. It's actually not as good if you shake it, is it? Wow. So the vinegar's getting, this is why I asked you to crush the eggshells, because they've got a higher surface area. So more calcium carbonate particles can react more easily with the vinegar. So as the vinegar is making its way down, you can see it all. Look, the bubbles of gas are kind of building up and up and up, and then let's watch that one pop out. Yeah! Okay, we'd better get on with the lesson, but that's so cool though. And yeah, in the end, you will hopefully get a balloon full of gas if you're doing the balloon thing. What is going on? Well, the calcium carbonate eggshells are dissolving in the acid, because this is what happens. Oh, can't we see this in a cool PowerPoint form, Lara? Yes, you can actually, in a minute. Okay, I'll give you this first. I'm just going to give you one question and I'll give you I'm saying this like it's a super treat, and then you get to watch a PowerPoint about what is happening to the calcium carbonate in the coral reef. But first of all, just to check you've understood, here we go. I just need you to come up with 3 words to describe, to make this a full sentence. More carbon dioxide in the atmosphere means something carbon dioxide is absorbed by the oceans. This means something hydrogen particles in the water. So the ocean is something acidic than it used to be. I'm going to be mean. I'm not even going to give you the options. If there's more carbon dioxide in the atmosphere, that means something carbon dioxide is absorbed by the oceans. This means something hydrogen particles in the water. So the ocean is something acidic than it used to be. Okay, the answers are more carbon dioxide in the atmosphere means more carbon dioxide is absorbed by the oceans. This means more hydrogen particles in the water, so the ocean is more acidic than it used to be. Yeah, sorry, the answer is more. If you put loose hydrogen particles in the water, I would totally accept that, because that is not wrong, and that would also mean that the ocean is more acidic than it used to be. But yeah, it's more. Right. Okay, let's just move straight on to the PowerPoint. You ready? So, we've got our calcium carbonate particle in our polyp skeleton, our coral reef, and we've got these loose hydrogen particles. Let's just focus on one loose hydrogen particle and see what happens. Well, it bonds with the carbonate in the calcium carbonate. In fact, the hydrogen bonds more strongly to the carbonate than the calcium does. So what happens is it becomes soluble in water, that particle, and it just gets taken away. It dissolves in the water. Oh no! So that's a carbonate particle, and the calcium is now all on its top, and it's surrounded by water particles, and that's soluble in water as well. So that leaves as well, that dissolves, and you're left with a dissolved coral reef. Awful. So I've been saying, until I researched these lessons, as far as I was concerned, eggshells were calcium carbonate and little coral skeletons were calcium carbonate, so they were the same. It's not actually quite true. If you did the periodic table lessons with me, everyone loved the periodic table lessons. One of those lessons we learned that carbon particles, like just carbon particles, can bond with each other in a certain way that means you get diamond, or they can bond a different way and it gives you graphite that you can like write in with a pencil. It turns out calcium carbonate is very similar. Calcium carbonate can be arranged in a certain way that it's called calcite, and that is what is in eggshells. Or it can be arranged in the other way, you don't need to remember these words, which is aragonite, and that's what's in polyps. So there's slightly different types of calcium carbonate, and it turns out the one that's in coral reefs, it dissolves slightly more easily. So why is this model not great? Well, it's not great because obviously we have added an actual acid, and the ocean is not an acid. It's just more acidic than it used to be. But it's also not great because eggshell is a bit more robust and doesn't dissolve as easily in acid as coral reef skeletons do. Sad times. Right, and as you can see, what happens eventually is that carbonate particle breaks down and you get water and carbon dioxide. So carbon dioxide going into the atmosphere as well. Oh no, that's not good. So this is what you've collected in your balloon, is carbon dioxide. Right. All that was deeply sad times, wasn't it? One more question and then I'm going to tell you about different types of coral reef. So I've just said to you that the problem with ocean acidification, the ocean becoming more acidic, is that it dissolves coral reef skeletons. It dissolves coral reefs. And that is true. If you've been really listening carefully, can you think of another problem with there being lots of loose hydrogen particles in the ocean? It's a real toughie. There's a sort of picture which might help you a little bit. It's good brain exercise. Can you see another problem with there being a lot of hydrogen particles in the ocean? So we've gone back to the beginning again. Here's the carbonate particle and here's the calcium particle. You remember that to make their skeletons, coral has to take carbonate particles and calcium particles and put them together to make calcium carbonate? What is the problem with there being lots of hydrogen particles in the ocean? Well, it makes it a lot harder for that to happen because you remember hydrogen particles bond with carbonate more easily than calcium does. So the hydrogen comes along, sneaks in, grabs the carbonate, and so the coral reef actually can't form its skeleton either. So it not only dissolves skeletons that are there, it makes it harder for polyps to build their skeletons because these carbonate particles are getting grabbed by the acid, if you like, by the hydrogen. And the calcium's, all on its tot. I know. Right. There will be a small test about what I've said later on in the lesson, but I think first of all, we should learn about different types of coral reefs, because we all talk about the Great Barrier Reef. Maybe you don't actually know why it's called the Great Barrier Reef. So there's three main different types of reef that some people talk about four, but most scientists sort of recognise three. So I thought, I'm just going to go into mini lecture mode and tell you a little bit about these three different types of coral reef, and then we'll play a very short game. Very short. But here we go. Right, three different types of coral reef. You've got your fringing reef, you've got your atolls, and you've got your barrier, which is the one everyone's heard of, right? Because of the Great Barrier Reef. So, fringing reefs. I'm trying to put on a lecturer voice. Fringing reefs. They are the most common kind of reef. They grow next to the shore, and they may be separated from the shore by a small lagoon. What is a lagoon, I hear you ask? Well, it's a shallow body of salt water separated from the sea. It makes more sense when you see a picture. Here's a fringing reef, look at that. Does it get better than this? That is a photograph of a coral reef taken by an astronaut on the National Space Station, which is orbiting the globe. So you can see here, right, this is the Pacific Ocean, very dark blue. This is the reef here, kind of blocking the ocean from the land. And in between the coral reef, this sort of brown-white line, and the land, we've got this gorgeous light blue colour. That's the lagoon. You remember? What's a lagoon? It's a shallow body of salt water separated from the sea. There we go. So that's why the water is such this gorgeous blue colour, because it's very shallow. So this fringing reef, it isn't actually on the coastline. You know, you wouldn't be paddling on it if you paddled in the sea, but it's just got a very shallow lagoon dividing it, okay? Here's a sort of close-up of the different parts of a fringing reef. You've got your inner reef, your reef crest, and your outer reef, or the forereef. So this is why they make such beautiful little places for fish to lay their eggs, for sharks to raise their young, because it's lovely, warm, shallow water. But it's also useful for humans. This reef crest in particular takes a right battering from waves, this bit here, which means that it protects, if you live on a harbour or you live on a beach, say, it protects those things from very big waves and storm damage. It's good, isn't it? Right, did you take all that in? Let's go to the next reef. The next kind of reef is an atoll reef. It's like a fringing reef, but it's grown around a volcanic island, and then the island sinks, right? So here's an awesome diagram that I found. So here's the coral reef in white. This bit in the middle is the island that is sinking, and this bit here, in between the reef and the island, that's the lagoon, yeah? So eventually the island sinks, and you get left with this gorgeous kind of circular or horseshoe-shaped lagoon with a reef around it, but no land in the middle. So this is, someone told me how to pronounce it on Facebook yesterday, and I can't remember. Nakuro, is it? Atoll, which is in the Pacific Ocean. If you look it up on a map, you'll find that it's actually lots and lots and lots of different islands all together. Look, isn't that amazing? So quite a few hundred people live there. So that is an atoll reef, right? So it's got that very distinctive circular shape. So there would have been land there where that lagoon is, and then it's sunk down below the water. And finally, barrier reefs. It's like a fringing reef, but it is totally separate from the land. So it's a much deeper lagoon in between. As usual, it's easy just to show you a picture. So here's the Great Barrier Reef, all photos by NASA. If we zoom right in, can you see this is the reef here? And obviously this is still really, really zoomed out. So this is massive. So there's a lot of ocean between the reef and the shore. And you can see, can't you, it's a much, much darker blue colour. So this is a much darker lagoon. It's almost just ocean, isn't it, really, and not lagoon at all. But yeah, I've put deep lagoon there. Here's another stunning photo. So yeah, this is, the Great Barrier Reef is actually lots and lots, like nearly 3,000 little reefs all joined together. So that's the reef and that's the lagoon in the middle. So if you compare that to that fringing reef we looked at, you see the colour of this water. That lagoon is really shallow and therefore warmer. Whereas this one, the Great Barrier Reef, that water is very, very dark blue. So it's a much deeper lagoon, if it's a lagoon at all. Right, let's play What's the Word? So I'm going to give you three clues, three descriptions of a different kind of reef. And I want you to match up the letter to what kind of reef the answer is, and then put the letters down and you should spell a word. So if it's an atoll, then you write an A. If the clue is describing fringing, then write a T. And if it's barrier, then that letter is R. Here we go. So the first clue is it's a deep lagoon. It's got a deep lagoon between it and the shore. So this reef has a very deep lagoon between it and the shore. So the first letter goes in there. Is that atoll, fringing, or barrier? The next clue is it's a reef shaped like a circle. Is that atoll, reef, or barrier? And the third clue is it's the most common type of reef. It's quite tough because I only told you this really fast. They were struggling with this on Facebook, coming up with all kinds of different words. Which reef it has a deep lagoon between it and the shore? Which reef is shaped like a circle? And which one's the most common type of reef? If it's atoll, write A. If it's fringing, write T. And if it's barrier, write R. And what word have you got? The answer is, all right, the one with the really deep lagoon, like almost just the ocean between it and the shore, is the barrier reef. So you write an R. The reef that is shaped like a circle is an atoll. You remember it's gone around the island. So that's the A. And the most common type of reef, it is a fringing reef. So the word was rat. Well done if you got that. Let's just do one more of those. The first letter is a reef formed around a sinking island. The second letter is a reef separated from land by a shallow lagoon. And the third one is the reef in this picture. So in this picture, you've just got some land and then some dark blue and then some reef and then some dark blue. What kind of reef is in that picture? More, more, more. How do you like it? How do you like it? Just shaking my bottle to try and get all the calcium carbonate dissolved. Okay, the reef formed around a sinking island, that's an atoll. The reef separated from land by a shallow lagoon is the fringing reef. And the reef in that picture is a barrier reef. Oh man, I got this wrong, didn't I? Oh no! Oh no! The secret word is... Man, do you know what? This is because I only taught this lesson once on Facebook and not twice, so I didn't pick up the mistake. That's the wrong way around, isn't it? Wait, I'd better fix it. Just for... Here we go. Right. That's wrong, isn't it? Separated by a shallow lagoon. That's a fringing reef, so it should be T. I know. I just need to put these the other way around. There. That's better. Wow. I'm really sorry. If you managed to get that right, I'm going to go to Facebook in a minute so the people who are watching live will no doubt be ranting hard. Well, if you got that right, well done. If you spotted my deliberate mistake to test you. That's right, isn't it? Around an island is an A. The reef in that picture is a barrier reef, so that's the R, and the fringing reef is a T. Yeah, nailed it. Okay. Sorry. Right, I've got some questions for you. I mean, they're not that easy. Like, some of them are kind of GCSE level questions. But what I'm gonna do is I'm gonna stay silent. I know I never do, but I'm gonna stay silent for 15 seconds, maybe 10, 12 seconds. I'm gonna stay silent for, and you can try and write down the answer or say the answer out loud. And then I'm gonna put some clues on the board, so you've got another 10 seconds to just choose which one you think is the right answer if you were really struggling, okay? So you've got 12 seconds, just look at the question and try and come up with an answer. Go on, do it, just write down anything, doesn't matter if you're wrong. And then I'll put the multiple choices up and you could be like, oh yeah, okay, it's that one, if you weren't sure, all right? And we'll do that like 5 times. And then it's the end of the lesson. Here we go. Question 1, what are coral skeletons made of? Sounds like, I should have put coral reefs, really. Coral skeletons makes it sound like a children's book. What are coral skeletons made of? Okay, I've got to 12 in my head. Have you written it down? Your options are calcium bicarbonate, sodium bicarbonate, or calcium carbonate. The answer was calcium carbonate. Well done if you got that right. Okay, moving on. You can always come back if I go too fast, obviously, because this is staying on YouTube. Catch up. Question number 2. Explain what is meant by the term ocean acidification. I'll count to 12 and then I'll put you some clues on the board. What is meant? What does ocean acidification mean? You don't have to write a big long paragraph, just a few words is fine. Okay, here's your clues. Is it the ocean getting more acidic than it was before? Is it the ocean becoming less alkali? Is it the ocean becoming acidic? Or is it the ocean becoming alkali? Or is this a trick question? The answer is, I was thinking that you would say the top one, but actually the second one is absolutely fine as well. If something's becoming more acidic, it is becoming less alkali. So well done if you got that. Again, we will do a whole series of lessons on acids and alkali because they're very cool. But yeah, if the ocean is a bit alkali and then it becomes more acidic, it's totally correct to say ocean acidification means the ocean's more acidic than it was before, but it is also less alkali than it was before. Right, moving on. Question 3. What causes acidification? 12 seconds. And your options are, is it carbon dioxide in the atmosphere? Is it the oceans warming up? Or is it overfishing? Which one of those causes ocean acidification? It is carbon dioxide in the atmosphere. Well done if you got that. It is quite confusing. But yeah, carbon dioxide in the atmosphere is what causes acidification. Question 4. Why is acidification a problem for coral reefs? These are really tough, aren't they? Really tough. Why is acidification a problem for coral reefs? But it's good brain exercise to just really struggle and not have a clue. And then I'll give you some options. Right, your options are, is it that it dissolves their skeletons? Or does it mean they've got less carbonate to build their skeletons with? Or does it dissolve their skeletons and mean that there's less carbonate for them to build their skeletons with? Does it dissolve their skeletons, mean less carbonate for them to build their skeletons with, or both, basically? It's both, isn't it? It is both, but any of those is correct. That's why I didn't put both, because if you said any of those, extremely well done, because it does dissolve their skeletons and it means they have less carbonate for them to build their skeletons with. And if you put both of those, then fantastic. But yeah, I'd be very happy if you knew any of that now. All right, finally, question 5. Here's a diagram of 3 types of coral reef. Can you complete the labels? So this first one is a fringing reef, but what's this one and what is this one? What is the feature marked A? And can you write a fact about each type of reef underneath its image? quite tough, this one, isn't it? The diagrams are quite odd. Okay, I've got the first one, the first label for you to put in is the barrier reef, because it's got this very deep lagoon on either side. And the last one is the atoll, so it's got the circle in the middle, and that is indeed a lagoon. And a fact about each type of reef, well, it's entirely up to you, really. You could say that the atoll one is grown around an island that is sinking. You could say that the fringing one is the most common. You could say that the barrier reef has a very deep lagoon, or you could even say that a barrier reef is the largest reef in the world, couldn't you? The Great Barrier Reef is the biggest barrier reef and the biggest reef. It can be seen from space. Right, that is the end of the coral reef show. I'm going to be so sad when we stop learning about coral reefs. We've got one more lesson left, like I say. I want to do a little bit about coralized fossil next week, because that can be found in places that are not now in the sea, which is interesting if you live on land, like me, and not in the ocean. And I'll do a bit of a quiz as well, just to kind of see how much we've learned, a bit of a summary. And then, yeah, it's the summer holidays for 6 weeks. So if you are supporting me, if you are one of the people who has signed up to help to pay my wages so that I can do all these lessons and Lego Storytime shows, then most of my summer holiday is going to be spent writing your supporter magazine so that I can give it to you to say thank you very much for supporting me, because best job ever, would not obviously be able to do my job were you not paying me, so very grateful. I'm just going to go to my Facebook page. Oh no, I'm still doing that thing. Facebook, oh no, Facebook has started saying on my computer that something is wrong and that it can't pull up the page. That's weird, but it was okay on my phone. All right, let's go incognito. Doesn't matter if I can't pull it up on screen. I'll just have to log off, and then I'm not logged in. I'll have to log off and go and look at my comments. That's annoying, though. Do I have to do that? Meta are apparently working to fix it as soon as possible. I'll try opening a new window, just in case it works. If you have not left me a comment, yeah, you should probably just go, sorry, this is really boring. Let's have a look. Comments? Oh, brilliant. Can I see them? Yeah, I think I can. That's weird, isn't it? It's just that one window. Hello, Bastian. I knew you were here because you got in super early. Hello, Suki and Osrin, Eunice and Sarah. I nearly said to you before. I was like, of course they will be there because it's Science Day. Oh, hello, Hannah and Thomas. You may well not be here now. Quite a few people have probably been like, we've got stuff to do today. Hello, Evie. Oh, and hello, Solomon and Jeremiah and Edwin. Hello. 8 art. Yeah. Good one. Well spotted. Oh, and Mary. Hello, Mary, as well. Fact, calcium carbonate is also found in chalk. Yes, because what is chalk? It's just billions of sea creatures, isn't it? Teeny tiny ones with calcium carbonate skeletons that have died, fallen to the bottom of the ocean and built up and up and up and up over like millions of years. And then the ocean moves and then we see them as clear. Oh, chalk blows my mind. Chalk is so awesome. Hello, Thea. Good to see you. Hello, Alice. 8 is a lagoon. Nice. Hello, by the way. Hello, Charlotte. Coral reefs dissolve. I knew coral cannot form. 8, brilliant. I'm loving these answers. Laurie is here. Good. Hello, Imogen and Ophelia. Yeah, it's your science day, isn't it? And Laurie and Flynn. Hello. And Aurelia. Hello, Aurelia. And Juaria and Ryder. And Laurie and Flynn are just shouting, rats, at me. Correct. Good. Oh, we would have been very sad to have not seen those comments. Thank you for your comments. And right, yes, I will see you, some of you at 2 o'clock for Lego Storytime show about dogs, which I need to set up again. Lego Storytime show is ridiculous. Do you want to have a taster? Look. It's all completely in the wrong order, so I have to go and set it up again. I will do that now. Thank you for joining me. I'll see you very soon.